Okay, first I'm going to apologize in advance for the abundance of example problems here. And it really won't take us that long to go through. I just wanted to make sure I kind of cover my bases here and give you all of the examples you need to succeed and know how to do well in these problems that we're going to solve. Alright, so first one, we know pretty much the basics of solving square root problems. I know you did it in Algebra 1. So I'm going to start easy and then we're going to build and get a little more difficult or just different than what you haven't seen before. Okay, so when we solve square root equations, the first thing we need to do is get the radical by itself. Okay, that is a must, something we have to get done. So here with this first option, it's already by itself, so the first step is totally done for us. Okay? So then after that first step, the second thing we need to do is, in order to solve for the variable, we have to get rid of the radical. So we do that by undoing it. You undo a square root by squaring. So we're going to square that whole side, but what you do to one side of an equation, you have to do to the other. So we're going to square both of them. 3 squared is 9, and we already know that the square root of a radical cancels one another out. So we'll just have 9 equals b minus 1. And now it's just a simple one-step equation that we solve. We add 1 to both sides, 9 plus 1 is 10, and 10 equals b. Now I will tell you, just like you've been taught so many other times, you have to check your solutions to make sure it works, because you can create extraneous solutions here. So check, plug 10 in, 10 minus 1 is 9, the square root of 9 is 3, 3 equals 3. So that checks out. So 10 is our solution for the first one. The second one. Alright, so here, our objective is to get the radical by itself, but you'll notice that both sides have a radical. So that's fine. I would clarify that I would say that the radical is by itself on both sides. So really, we can just do what we did up there. It's already by itself, so now we can square both sides, and squaring that just undoes, is that a word? The radical. So we'll have 2m minus 6 equals 3m minus 14. And now, once again, it's just a two-step equation that we can solve. So we'll subtract our 2m, and we'll get 1m minus 14 equals negative 6. Remember that negative needs to be brought down. And then we can add 14, and negative 6 plus 14 is 8. And so we'll get 8 equals 1m, or 8 equals 1m if you want. I know a lot of you divide by 1, and we'll get m equals 8 still. And then again, we can check. 2 times 8 is 16, right? Yeah, 2 times 8 is 16. 16 minus 6 is 10, so we have the square root of 10. 3 times 8 is 24. 24 minus 10 is the square root of 10. Square root of 10 equals the square root of 10, so that checks out as well. So 8 is our solution for number 2. Alright, for number 3 here. Some of you might say, what? 1/2 power? If you remember from this whole lesson, this whole chapter so far, not lesson I guess, this whole chapter, anything raised to the 1/2 power is the exact same thing as a square root. So this can actually be written as the square root of 20 minus r equals r. That and that are the exact same thing. So here we can simplify. Is the square root by itself? Yes, it is. So we need to undo the square root by squaring. So I'm going to square both sides. So here we'll get 20 minus r equals r squared. Now this is where it gets fun. This is where we're going to have to recall back to our quadratic equation chapter, because now we have a quadratic. So I can't just take the square root, because it's going to put us right back to that first part. So we have to solve the quadratic. Remember, when we solve a quadratic equation, we need to get the equation equal to 0. So I'll subtract the 20 and add the r to this side. and I'm going to write it in standard form. So it's going to be 0 equals r squared plus r minus 20. And then from here, there was many different ways we learned how to solve a quadratic equation. We could solve it by completing the square, we could solve it by graphing, we could solve it by factoring, we could solve it by using the quadratic formula. Many of you, I'm sure, will use the quadratic formula. So your A, in this case, would be 1, B would be 1, C would be negative 20. However, that's going to be a lot longer of an explanation. If you need to, go back to chapter 5 in our notes and review, I think it was lesson 8, the quadratic formula. Go back and look at that and review how to do it if you need to. I'm going to solve this by factoring because it's going to be a lot quicker. Because looking at this, one, we've done factoring more recently, and I know because my coefficient is 1 here, I know the factors of negative 20 that add to positive 1 is going to be r plus 5 and r minus 4. Okay, so those are my factors, because 5 times negative 4 is negative 20, and 5 plus negative 4 is positive 1, so that checks out. So to solve it, remember, we set each factor equal to 0, and we'll get r is negative 5, and r is 4. Now remember I said make sure you check your solution, so here we need to make sure we check them. 4, I'll plug that in. 20 minus 4 is 16. 16 to the 1/2 power is 4, and 4 equals 4. So 4 checks out, 4 is a solution. Let's do negative 5. 20 minus negative 5 is 25. The square root of 25 is 5. But 5 doesn't equal negative 5. So this is considered an extraneous solution. So it does not work. It does not make the equation true. So our only solution for option 3 is 4. Okay. Then let's look at example 4. At this point, students, if you're starting to get the hang of it, I encourage you to pause the video, attempt problem number 4. If you get it right, fast forward it to example 6 where we start changing things up and it looks different. If you don't get it right, watch the video throughout here and then watch the next one as well. Or pause it after this one and try to solve that one. See if you can do that. Alright, problem 4 here. Is our radical by itself? Yes it is, so I don't have to do anything there. Second thing, we have to undo the radical. We have to undo the radical by squaring. So let's undo that, and we will square both sides there. So doing this, the radical will get undone. So we have 2v minus 7. Remember, v minus 3 squared is not v squared plus 9, or v squared minus 9. It's v minus 3 times v minus 3. So we have to recall our last lesson of FOILing. V times v is v squared. V times negative 3 is negative 3v. Negative 3 times v is negative 3v. Negative 3v and negative 3v is negative 6v. And negative 3 times negative 3 is positive 9. So this is v minus 3 squared. So just like we did then with problem 3, we once again have a quadratic equation, so we need to get it equal to 0. I'll subtract 2v, add 7. And we'll have 0 equals v squared minus 8v plus 16. Again, we can solve this by factoring, so I'm going to choose factoring. If you're not comfortable with that, use the quadratic formula. Or completing the square, whatever you're more comfortable with. Factors of, so my c is positive, and my b is negative, so I know both my signs are going to be negative. My only factors of 16 that add to 8 are 4 and 4. So my answer is going to be v equals 4 for both, once we set each factor equal to 0. So I'm going to take v, I'm going to plug it in. 2 times 4 is 8. 8 minus 7 is 1. The square root of 1 is 1. And 4 minus 3 is 1. 1 equals 1. That checks out. Okay, let's try problem 5. Now problem 5 is a little different because once again, or it's the first time we haven't had the radical by itself. So for 5 here, we're going to have x equals 5 plus, remember 3 minus 11 to the 1/2 power is the exact same thing as 3x minus 11, the square root of 3x minus 11. Sorry. So we have to ask ourselves, is the radical by itself. And for the first time, we can say, no, it is not. So we need to make it by itself. So we have to get rid of this 5 here. We're going to do that by subtracting 5. So we're going to have x minus 5 equals the square root of 3x minus 11. Now is it by itself? Yes, it is. So now let's undo it. And we can undo it by squaring both sides. So again, here, we're going to get a quadratic. It's going to be x squared minus 10x plus 25, because it's x minus 5 times x minus 5, FOIL it out, and that will equal 3x minus 11. So we need to get it equal to 0, so I'll subtract 3x and add 11 to both sides, and I'll have x squared minus 13x plus 36 equals 0. Again, we can solve it by factoring. So I'm going to factor it out. It's positive c and a negative b, so my signs are going to be negative, or x minus. And factors of 36 that add to 13 are 9 and 4. So my solutions are x equals 9 and x equals 4. Again, let's check them. And I'm going to plug it in its original form. Okay, not with subtracting the 5. So here I'll have 9, so we'll say 9 equals 3 times 9 is 27, 27 minus 11 is 16, the square root of 16 is 4, 5 plus 4 is 9, 9 equals 9, that checks out. Let's try 4. 3 times 4 is 12, 12 minus 1 is 1, sorry, the square root of 1 is 1, 5 plus 1 is 6, 4 doesn't equal 6. So x equals 4 is an extraneous solution, but x equals 9 is not. That works. All right, let's go on to question 6. Now, I know for these, I said change it to a square root, right? But you really didn't have to. You could have kept it as a 1/2, because all we're doing then is we're squaring that, right? So our job here is we're going to get the radical, even though there's not a radical, we're going to get the piece with the rational exponent. We're going to get that by itself first, and then we're going to undo that. So with 509 equals n plus 24 to the 3/2 power minus 3. To get this by itself, we're going to have to add 3 to both sides. So we're going to have 512 equals n plus 24 to the 3/2 power. Okay, now I could write this as a radical, but I'm not going to. It would be the square root of n plus 24 cubed, and we don't need to mess with that, because that will just look confusing. Like I said, we could have just squared this right away, so we could use the property of exponent, our exponents here, and say, I need to raise this to what power to make this exponent 1? You just multiply it by the reciprocal here, and that's going to be 2/3. So we raise that to the 2/3 power, and we raise this to the 2/3 power. So 512 to the 2/3 power is, I have it written down here, 512 to the 2/3 power is 64. Okay, now if you didn't get that when you typed it in your calculator, it's because you typed it in wrong. It's 512 caret parentheses 2 divided by 3. And that's how it needs to be typed in. So we'll have 64 equals, now this, like I said, when we use our property of exponents and multiply, we get 1. N plus 24 to the first power is just n plus 24. So we have a linear equation, we just need to solve. Subtract 24, we get 40 equals n. And again, we can check it. 40 plus 24 is 64. 64 to the 3/2 power must be 512. And then 512 minus 3 is 509. So that checks out and that works. Let's look at number 7. Okay, for 7 here, we have 4 plus 2x to the 3/2 equals 690. Again, you want to try to get the group that's raised to the power by itself, aka the radical by itself. So with this, I will subtract 4, and we'll get 2x to the 3 halves equals 686. But then, don't get confused, this 2 is not connected to that x. The 2 is not raised to the power of 3 halves, just x's. So I need to divide by 2. And we would have x to the 3 halves power equals 343. Now my my group that's raised to the power is isolated, so I have to try to figure out what I need to multiply that by to make it 1, and it's the reciprocal, so 2/3. And then I need to take 343 to the 2/3 power, and doing so I get 49. So I can check this, plug 49 in. 49 to the 3 halves power equals whatever number, multiply that by 2, gives us 686, add 4, gives us 690. Okay, let's try 8. Alright, so we have 3k plus 123 to the negative 1/2 power, and that equals 1/6. Here, our group that's raised to the radical is already isolated. You could make it a fraction, do 1 over 3k plus 123 to the 1/2 power, but it's really not necessary in this case. We can just raise it to the reciprocal power, which is going to be negative 2 over 1, or just negative 2. But then we also have to raise this to the negative 2 power. So doing that, this would be negative 1/2 times negative 2 is positive 1. So we're going to have 3k plus 123 equals 1/6 to the negative 2nd power is actually 36. And then we can subtract the 123, and we'll get 3k equals negative 87 divided by 3, and we'll get k equals negative 29. So there's your solution. You can check it, but it will check out to be 1/6 or whatever that is, 0.17 repeating. And then lastly, let's look at example 9. We have n over 2 to the 5/3 power equals 243. Our group that's raised to the radical is already isolated, so we just have to undo that, which again would be multiplying by the reciprocal, raising it to the power of the reciprocal, which would be 3/5. That we will get 15/15, which is n over 2 to the 1st power, and 243 to the 305th power, 243 to the 3/5 power is 27. And then we have n divided by 2 equals 27, undo, multiply by 2, and we'll get n equals 54. And you can check it, and that works out as well. 54 divided by 2 is 27, 27 to the 5/3 power is 243. Any questions? Don't hesitate to write them down and bring them in and ask.